Hello all, welcome to the video lecture series for the subject operating system. In continuous of the previous topic, I am going to teach you all about the disk scheduling algorithm scan, right? So let me tell you what is this scan is all about. The disk arm moves in a particular direction and serves the request coming in the path. It may either move in the left side direction or else right side direction. And the path and after reaching at the end of the disk. See here, this are the request, but we made end is that is starting is 0, end is 199. In this particular scan, it will move start from any head position and it will move at the end of the disk. It won't stop at the request, it will move at the end of the disk. That is the only difference we can find here between the scan and the previous algorithm. And whenever it reaches at the end, suppose say for example it is at 50 and it is reaching, all the service has been done and it is reaching 199. After it is reaching at, it will take the next opposite direction and the direction will be from 199 to all the other end to the 0. It will reach to the exact position and it will point exactly at 0, right? And whenever it is moving from left to right and it will serve all the requests in this path, whenever it is moving from right to left and it is making all the requests from the path, right? So this is the difference between this scan, and it is going to move from either of the direction to provide and access, and the request has been satisfied. So this algorithm works as an elevator, right? And you know very well how this elevator is working. Actually, it will move from up or down, right? It will move from down to up. It will serve all the path. Say for example, you are getting into the elevator at number 0 and you want to get down at some place called 7 or 8, and the elevator will not stop anywhere after this 7 or 8. It will make the complete request and it will reach to the maximum distance it has been covered. And as a result, the request or the mid-range or service more than the arriving behind the disk arm, and it will wait until this process has been completed. So we are going to check what is the disk arm, and we are going to check what is the total distance covered by this disk arm. So let's check whether this particular algorithm is much effective than the previous one. Let's check. So now the request has been made, and here you can check the question. The suppose the request has been addressed 82. The same request I have taken for all these three algorithms: 82, 170, 43, 140, 24, 16 and 190. And the read and write arm is at 50. And it is also given that the disk arm moved towards the larger values. So it is moving from 50 to larger values will be served first, and then the shortest value. So this has been clearly given in this question itself. So we are going to check whether it is moving to the larger values or else smaller values. According to this, the algorithm proceeds, right? I hope you understand how this larger and shorter works. Now let's say this particular header has been pointed. Based on this question, it is at 50. So we'll place this particular header at 50. Right now this header is going towards the larger value as is given below, and we are going to serve all the requests. Say for example, we'll draw this particular scan first so that you will understand. Now it is traveling from 50 to 199 as I told you. So this is the path. Now check what all the requests between this 50 to 199. We have the first request is 82, so 82 will be served. So I have mentioned that 82 will be served. The second request is here it is 140, 170 and 190. So here it is 140. We have this 140 in and around here, and then we have this 170, and then we have this 190. Here it is exactly, and it is exactly stopping at 199. The previous one, that is first come first serve and shortest seek time, this particular disk, that is particular arm, will not move to the 199. That is the end of the disk. It will not move thoroughly, and it will be end exactly at the request. But here this algorithm, I already explained, it takes the header and it will definitely reach at to the end. This is the first sequence. Second sequence is exactly where it has been pointed and where it is ending exactly, that is a point, right? So the sequence has been ended here. that is 199. And what is the last request has been made here? So you can check it. The last request is 16, 24 and 43. 16 is the least one. So the header will start here and it will exactly move to the 16 and it will stop here, right? So now we have this path. What are all the path which has been served here? We have the request at 43. So here it is 43. We have the request at 24. Finally, it is reaching to the 16. Now let's have this head position. This is number 1, number 2, number 3, number 4, number 5. And this is number 6. And finally, this is number 7. So now you can able to understand how exactly this positions has been moved. So here it is 82 and 82 to 140, 140 to 170. Sorry, this request is 190 to 170 is not a actual position. So even though I have mentioned, right? So that let's check how this positions has been made finally. So now you can check it. We have to find only, see here, the request has been started at 50. It is ended at 199. And it started at 199. It is ended at 16. So we have only two end positions, 50 to 199 and 199 to 60. So we are not going to calculate wherever it stops because it is not stopping anywhere. It is going to start from 50 and it is ended at 199. Wherever it transfers, all these values has been saved. That is the point, right? So now let's check how this calculations has been made. Now the head position is at 50 and it stops exactly at 199, exactly here. So the head position will be calculated in this direction. So you can check it. 199 minus 50 plus. We have only two traverse, that is 199 to again 16. So that is the only traverse we have. So we are going to mention it as 199 minus 16. So the stop point is, here the stop point, start point is 50 and it is ended at 199. Here it is. This is number 1. And it is started again in 199 and it is ended exactly at this position called 16. That is number 2. So why this only two head positions here? Here I have mentioned all the positions of the head which is served, not stopped. That is the point. Which is served, not stopped. The head is actually, we have, this is the first point and it is slightly moves and it stops at the position here. And again it is starts here from this direction and it is stopped at the last position, right? So it starts here, hence here, again it starts here, hence here. So totally we have only 4 points, 50 to 199, again 199 to 16. So 4 end points and 4 points has been traversed, right? So what is the answer now? 199, that is 149. Again it is, the value is 332. So you can check whether the total distance covered by this scan is much better than the previous algorithm or not, right? I hope you understand how the scan actually works, and this is what about the scan positioning and algorithm means disk scheduling algorithm. Thank you.